Hey guys, it's Shah here at the Tech Borg, and today's video we're going to be making a recursion program. For those of you that don't know what recursion is, please do search on YouTube. It's a pretty straightforward concept. So how it works is you'll have a function, right? So you have a function, and then what happens is the function is essentially just called upon again and again inside another function essentially. So it's like, so for example, if you want to find the factorial of a number, so 3 factorial is literally 3 times 2 times 1, right? Now, in order to do this, well, this is an example of recursion. So what you can do is you can first say, okay, so whenever I put something in a function, say if I put 3 in the function, I want you to return that value times by function minus 1, i.e. the value that we're currently on minus 1, and return that. So let's try to put this into a concept. For those of you that don't know what recursion is, it's better if you guys watch a prior video on recursion, just so you get a general understanding. Recursion essentially is just using a stack, essentially. For example, like holding something in memory while the others are opened up. So for example, I'll show you how this works once I write the code. So first we're going to define a function, which is going to be 4 factorials. We're going to have define factorial n, right? Then now, recursion requires a base case. For those of you that have done some research, so the base case is basically our lowest value we can go to in a factorial, which is 0. Well, 0 factorial is 1, so if n is equal to 0, we want to return a 1, right? Else we want to return, like I said, it has to be the number times by 1 minus the previous number. So n times factorial n minus 1. That's all it is. Now, if I just print our solution, print say 3, so save it and run this. Alright, syntax error. Oh, sorry, it should have been factorial. Fact. Now if I save this and run this, there you go, it's output 6. We know 3 factorial is indeed 6, and we know it's working. Now how does this work? Well, I'll take you through this step by step. Now first of all, we said let's let fact3 equal 1. Now when we let fact3 equal 1, the function tells us that we need to go from there to the else statement, right? Because n is not equal to 0, it falls in the else statement bracket. So it's going to end up returning n times factorial n minus 1, which is going to return 3 because n was 3 times factorial of 2, which is further going to go down even deeper now, because factorial of 2 is same as, well, factorial of 2, let's see, so 3 times factorial of 2. Now what is the factorial of 2? Factorial of 2 is 2 times the factorial of 1. So 2 times the factorial of 1. And then what does factorial of 1 go to? That goes to 1 times the factorial of 0. And then we've reached our base case, which I'll show you. So 3 times bracket 2 times, these brackets are just to help you understand, obviously. So yeah, so we're going to have 2 further brackets. So now this factorial 1 becomes 1 times factorial 0, because it falls in this else statement, right? Because n is 1. So 1 times factorial 0, right? And we know factorial 0 is 1, so this entire expression just becomes 1, because we've said here when n is 0, we want to produce a 1. So what our program does now is it does 3 times 2 times 1 times 1, and it produces a 6. This is literally how it works. It's like a stack based system, so it just, as you can see, it kept stacking on. So fact 3, fact 2, fact 1, and as you can see, it got bigger and bigger, like the size of the calculation, and that's what it means by holding a stack, basically. So let's see if it actually works. Let's see how efficient it is. To be honest, recursion isn't that great for very large numbers, because well, it has a very large space complexity, which is the idea that it takes a lot of space, because stacking means you need good memory. But yeah, thank you for watching, guys. I hope you guys enjoyed this. Again, this is just a very basic factorials. We looked at a base case, we looked at how to induce upon that base case, and I showed you how to break down a problem. Anyways, thank you guys, see you, bye.